Okay, I thought I'd do a little demo of, an app I built at the end of last week. This kind of came out of my interest in building voice integrated applications. I haven't done much with it, but it's always been kind of an interest. And specifically be able to like take a phone call and do stuff with it. A lot's changed in the past couple of years in the space, and this stuff has just gotten so much more tractable and powerful. So yeah, thought I'd just do a little show and tell. I guess I just miss show and tell from when I was a kid. So the workflows where I think voice, obviously would still be useful, or places where people are taking high volumes of calls, and they could use an assistant to help out with that, to triage, to route, to classify, to do other kinds of value add on top of the call, and or like off hours. So in this particular example, like imagine, if you will, a maintenance crew for a very large building that needs to be able to take maintenance calls at, all hours of the day. So we'll see data coming in to the call here, from the call onto the screen as it happens. It's kind of like a little switchboard application. And then we can see some of the, the conversation in the call and stuff's going to happen. So I'm going to go ahead and make a phone call on my phone. This is actually wired up to a real phone number, and I'll put it on speaker, and hopefully that all will just work and you'll be able to hear it.
Hello, Chad. This is Sam, the AI assistant for Frank's really high rises. How can I help you today?
Yeah, I have a little bit of a leaky faucet issue.
Would you like me to file a maintenance report for that leaky faucet?
Yes, please.
Great. Can you provide any additional details about the leaky faucet?
Yeah, it's in my kitchen. I think it's underneath the sink, and it's just a slow drip right now.
I filed the report for your leaky kitchen faucet. Your request number is 14. Is there anything else I can help you with today?
No, that is it.
Have a nice day. Goodbye.
Okay, so we saw our call come in. We got a work order filed as a request. You can imagine all different kinds of workflows there, maybe some rules around the kind of thing it is in terms of like routing the request to different people. I just think there's all kinds of opportunities here. And I think a lot of, organizations, companies are going to go into these kinds of automated workflows. You can imagine doing sentiment analysis on this, like, is the customer irate? Are they in so on and so forth? And we could triage or escalate. We could also kind of do summaries and things like that, roll up the data so that you could kind of see an organization dashboard, kind of get the pulse for the building or set of buildings for the day. So I just think there's all kinds of, interesting opportunities there. So this is a show and tell, and now I'm going to enter into the tech side of the show and tell. So if that just makes, like basically looking at Klingon makes your eyes glaze over, then you can turn the video off now. If you have any interest in chatting with me further about building this kind of thing, I love to talk about this kind of stuff. So always willing to have a conversation. So appreciate it. So let's just talk about the tech for a couple minutes here. The way that this works is we've got three different pieces to it. It's Twilio, or Twilio, however you're going to pronounce it, Elixir Phoenix, and OpenAI. It doesn't necessarily have to be OpenAI. It could be our own, models. They just happen to have a really powerful voice assistant platform that was kind of plug and play for me. And yeah, I learned a lot about WebSockets in this process. Basically, the way that the connection works is you get an HTTP1 request that comes in, and then it like basically requests an upgrade. That's part of the HTTP1's, I won't call it a spec, but part of the HTTP1 standard. And so you could kind of learn more about that if you want. Mozilla's got a pretty great explainer on all this protocol stuff. It's pretty fascinating. Doesn't actually come with HTTP2. Interestingly, it is only available in one. So that's kind of interesting. With the handshake process, we get some metadata that comes in. The one that we really care about here is the call SID. That's like the unique identifier for the call. And then with that, we instantiate a process inside of the Elixir Beam, the VM that Elixir runs in, and the VM that Erlang and Gleam also run in. And you get that instantiated, and that kind of manages our state for the assistant. And we also open up a connection with OpenAI, and that goes through the whole upgrade process on that side. And so now we actually, on this assistant, we now have a connection to OpenAI, and that kind of is where a lot of the functionality around interacting with the assistant lies. We return back a location to Twilio that says, hey, go here to connect to the WebSocket. And we open up a bidirectional WebSocket with Twilio. Now, one kind of interesting side note on this is that this WebSocket adapter is just part of Phoenix now. It was like a release or two back, created by Matt Trudell. And he is author of Bandit, the web server that powers Elixir Phoenix now. Has a pluggable architecture, a behavior called WebSock. If you implement that, you basically get WebSocket handling for free, which is really nice. And it gives you really low-level access, like frame-by-frame access to the data coming off the WebSocket, and lets you do all kinds of cool stuff. It's pretty straightforward to do those implementations, and then that just becomes part of the process of the server. Then we, at that point, we send a message back to the assistant, and we link these two things together. And so now their fates are inextricably bound. If one blows up, the other blows up. The call is not going to work if either one of these things stops working. So yeah, that's and at that point we have a connection, and we have data flowing in and out of the system. We've got audio coming in from Twilio, and we are pushing that over to OpenAI and getting text back and audio. And I'm a little amazed that it works as well as it does. It's got all these different hops. So in my little app, we've got a little abstraction around the assistant so that we can have different kinds of assistants for different kinds of purposes. And those could be located at different endpoints, different controllers. So you can imagine requests coming in for different clients. And that's maybe how you would handle multi-tenancy in a scenario like this. And then what we have is a bunch of events coming back from OpenAI, and then we pattern match on those and say, like, bang, if we get this thing, then we can do this thing. So in this case, it's like we, as audio is coming back in text, we get deltas actually. And this is kind of the way, if you've done any work with LLMs, like you get these streamed data coming back, delta by delta. So you get like word by word basically coming back. But we also get an event for like when we've kind of got a chunk. And that's what we save as like a message. So that's when you see the messages going back and forth. That's what that actually is. I will say, like, OpenAI comes with voice activity detection. That's like a thing in of itself, VAD. And there's other tools that you can do that for. There's native tools in Elixir. I can post a link to a blog post on how to do that natively in Elixir. But OpenAI kind of supports that. So that's how we get those chunks. And then we also have tool handling, which is, a feature that's become pretty popular, common, and powerful with LLMs now, where with a prompt, you can kind of tell them when they can actually execute different kinds of functions. And there's ways of giving them structured data so that they understand. Put the words, that word understands doing a lot of work there, but it gives them context for how to actually execute those tools. And so, basically it comes down to a tool name and some arguments, and they need to be of a certain kind, integer or string, so on and so forth. And we can validate those. But in any case, that's how that work order actually gets filed there. So yeah, this was less work than I expected. And I just thought the whole process, the way that this actually flows, is really interesting. And it also kind of reminds me about how good of a fit Elixir Phoenix, how good a fit the Beam really is for this kind of work. In fact, I was kind of chuckling at the idea that the original purpose of this process system really the many of the abstractions built on top of this process system in the Beam were originally for telecom. And so it's sort of like we've kind of come full circle here. And so maybe that's why this was, felt so ergonomic to me, is that in fact, the abstractions were really built for this kind of work, which I thought was kind of interesting. So in any case, if you have questions or you want to talk more about this, happy to have a chat. I just thought I'd do a little show and tell as we're getting kind of toward the end of the week here. And this kind of got me excited. So thanks a lot. And, shoot me a question if you have any. Thanks a lot.